Hi, my name is Allan Chan. I am a computer engineering major at Cal Poly San Luis Obispo. Today I'm just going to give a brief overview to you guys about my senior project, which I worked on in collaboration with Western Digital. As you may know, Western Digital is a maker of data storage products. They are very well known for making hard drives and more recently solid state drives. For my senior project, I was involved with doing an upgrade to this device here. This is called a Utopia. More specifically, this is Utopia 3.0. What it is used for is it's used for performing testing on hard drives at Western Digital. I'm going to just give you a brief overview of all the components on the board, and then I'm going to show you a little bit about a little demonstration in a moment after this. So first, board components. What I have here is there's a bunch of inputs and outputs. First, here is a USB port. This is used to connect to a PC to interface with the PC and control the board. Here we have a SIO port and a power output header, which is connected to the hard drive. And here we have a 4-pin power input header, which is used to supply power from an external power supply. The key components here are the PIC microcontroller and the FTDI USB to UART IC. I'm going to first talk about the FTDI part here. What this is a dual USB to UART IC. It is mainly used to convert USB data to UART data, which the microcontroller and the hard drive SIO port can process. These are independent ports, so they allow simultaneous command of the voltages and controlling of the hard drive. What I have here is like I said, the PIC microcontroller. This is used for controlling the voltages, mainly switching on and off the circuit, controlling this circuit up here, which is the switch circuit, and also regulating the voltage by controlling the circuit here, which is the voltage regulator circuit. It also features analog inputs. We are using about 8 of them to measure voltages that are coming into the board and voltages that are going out of the board, along with currents. Here is the back of the board. Most of these chips here are the MUX controllers, which are used for voltage regulation and the switching circuit. And the last piece of item I'm going to talk about is the switch here, which is used to manually turn on and off the power output. Okay, so now that I've gone over a little bit about the board components, I am going to show you a little demonstration about how this board works. What I have set up here is my laptop, which is connected to the board via USB, and I have a power supply here, which is set for 17-volt DC and is connected to the power input of the Utopia board. What I have set up here is 2 multimeters, which are going to measure the output coming out of the output header of the Utopia board. So let me turn this on here first. As you can see, it is reading 0 volts because the board is off. first I will turn on the board by turning on the power supply here. So now that I have 17 volts going onto the board, the switch is off right now, but I can use hyperterminal, and by sending commands to the board, I can turn on the outputs. And so on my multimeters, I am reading a 4.96 and a 11.92 volts on the outputs. Now these are the typical 5 volt and 12 volt outputs that you normally see on the input of hard drives, and they are marginally slightly off. That is because as this is a prototype, the exact resistors and exact circuit specifications were not completely exact, but with a little bit of calibration that is planned for later on in this project, we can set the outputs to be the exact 5 volt and 12 volt outputs. Now, as I mentioned before, we have features to voltage margin the outputs. So by typing a few commands, I can change the voltages readings on the outputs, and I can show you right now. First, I will set this 12 volt supply here to be, I don't know, we'll set it to 5 volts. So by typing the command here, as you can see, the voltage has changed to 4.97, which is fairly close to what I was expecting. And I can also put the command to turn off the device, or turn off the output, and that's simply with a power off command. Here you can see both outputs read 0 volts. Well, yeah, so I don't have a chance to demonstrate the SIO feature, but hopefully you have a good idea of how this board works and what it does. Well, I hope you learned something new, and I'll see you guys soon.